Good day everyone, I'm here to present my programming language, which is Common Business Oriented Language. So the expected learning outcomes. In this lesson you will be able to learn or to know the history of Cobol, the features of Cobol, its advantages and disadvantages of using Cobol, why you should use Cobol, its program organization, grammatical hierarchy and structure, its coding rules in Cobol language, how to accept and display values on screen, how to declare variables and store values to the variables, how to use common verbs in computing values, and how to use conditional statements. So, history of Cobol. So, Cobol was first designed in 1959 by CODASIL, or Conference or Committee on Data System Languages, which is a consortium formed in 1959 to guide the development of standard programming language that could be used on many computers. In late 1962, IBM or International Business Machine announced that COBOL is going to be their primary development language. COBOL edition 1965 introduces the facilities for handling mass storage files and tables. In 1968, COBOL was recognized and approved by ANSI Standard Language for standard commercial use. By 1970, COBOL had become the widely used programming language in the world. In 1982, ISO, or International Organization for Standardization, installed then SC5's first working group WG for COBOL. In 1985, the ISO Working Group 4 was accepted this version of the ANSI proposed standard. In 2002, the first object-oriented COBOL was released, which could be encapsulated as part of COBOL. In 2012, Computer World Service found out that over 60% of organizations still using COBOL. COBOL 2014 includes features like method overloading, dynamic capacity, tables, etc. Allows you to handle a considerable volume of data due to its advanced file managing capability. It is a logical structure in COBOL is easier to read and modify. It can be executed and compiled with machines like IBM, personal computers, etc. Testing and debugging tools are always accessible on all platforms of the computer. Therefore, it is a robust programming language. You can easily debug in COBOL as it has different divisions. Cobol was designed for business-oriented application. It can handle large volumes of data to its advanced file handling capabilities. So the advantages of Cobol. You can use Cobol as self-documenting language. Cobol language can handle massive data processing. It is one of the primarily used high-level programming language. Fully compatible with its past version, Cobol language can handle massive data pre-processing, processing. Resolution of bugs is easier as it has an effective error message system. Cobol is also widely used as self-documenting language. In Cobol, all the instruction can be coded in simple English words. So the disadvantages of Cobol. So it has a very wordy syntax. Cobol has the most rigid format. It is designed to handle scientific. It is not designed to handle scientific applications. The time needed to compile a COBOL program is quite greater than the machine-oriented programming language. So as you can see here, we have two examples. One is the format of the COBOL code, and the other one is the punch card or the card reader for the Cobol hardware. So we will explain the format later on. But the code should be fitted in the card reader. So why Cobol? It has billion of lines of existing codes with more added each year. It is designed for business, great compilers, run fast, relatively simple to learn, and the language keeps evolving. So what is the program organization? So a program is organized like a book. Under it is division, which has identification, environment, data, and procedure. The section is the logical subdivision of program language. Logic, I mean. Paragraph is a subdivision of section or division. It is either user-defined or a predefined name followed by a period and consists of 0 or more sentences or entries. Sentence is a combination of one or more statements. Sentences appear only in procedure division. A sentence must end with a period. A clause is used to specify how a data item is to be stored in the computer's memory. The phrase specifies the parameters that a program is called or the method is invoked. Word is a character string that forms a user-defined word, a system name, or a reserved word. So the grammatical hierarchy. So in identification division, so under it is paragraphs, and then under paragraphs is entries, and under entries is clauses. Environment division, under it is sections, under section is paragraph, and under paragraphs is entries, and under entries is clauses and phrases. In the data division, under it is sections, under section is entries, under it is clauses, and clauses under it is phrases. Lastly is procedure division. So under the procedure division is sections, under section is paragraphs, under paragraphs is sentences, and under sentences are the statements and the phrases. So here we coded the structure of a program. So as you can see here, this is the format, general format for a program. So here we intentionally left it blank because it is a sequence number where the specific code will be stored or found in. So in coding rules, just like I said, it is left blank. Then the compiler fills in the sequence number, just like here. Example of these sequence numbers. So from 1 to 6, it is left blank. Line 7 usually blank, but it can be putted asterisk or means comment line. Then a dash or minus, a continuation, and D for debugging lines. Column 8 to 11 is margin A margin or area A calls 12 to 72 or margin B. Then calls 73 to 80 is unused. So go back to the structure of the program. You can see here that we have area A, the area B we use in the structure of the program. And here, if you go beyond 72, the program would not recognize any word or comments that will be placed here. So the statements can be continued on the next line in area B. So continue thus constant through 71. So as you can see, put minus in column 7. Then continue constant with a or. I wasn't able to find any other example with this one. Continue constant in area B. As you can see, we use the dash to continue a specific value. If your value is too large to handle it. So things that go in area A. These are division headers, section headers, paragraph headers or paragraph names, level indicators or level numbers 0, 1, and 77, which will be discussed it later on. Declaratives and declaratives, the end programs, and class and end method markers. In Area B items, they are entries, sentences, statements, clauses, and the continuation lines. So things that go in Area A or B. These are level numbers, comment lines, the compiler directing statements, the debugging lines, the pseudo text. So here we have a example, just the divisions of the program structure. We have identification division, we have the program ID, and uh, then the environment division, the data division, the file section, the working storage section, the procedure division, and the main division, and the end program. So later on, we will discuss what are these divisions. So the main structure of Cobol. So identification division. So basically, only program ID is required. But you can also use this to to fully documented your code. Some interesting terms can be coded in the program ID. So the program ID is like a class, and hello is your the file, maybe your file name or the class name of your program. The procedure division is where you code the executable statements in your Cobol program. It is divided into paragraphs terminated with periods. So 100 dash main, then display hello, perform 200 sub, then go back. So it means uh, this uh, this these these paragraphs are called another language, maybe functions. So the functions like an exit program when coded at the end of the code program. Functions like stop runs when coded in the main program, and I prefer coding this in the place of stop run. So the goto causes an unconditional jump in program execution to the procedure that is named. So this statement should be used only in very special situation, for instance to branch an error routine that terminates the program from deeply nested area of your program. Overuse any of this statement is unnecessary and leads to spaghetti code. Don't even think of using the alternate forms of goto uh, exclamation mark. So in procedure division, to resolve ambiguity caused by not using periods, we will use statements like delimiters like end if. It is to end the if statements, if else statements, and perform to end the perform statements, and end compute to end the compute statements. So the perform paragraph name, so it execute all instruction in the paragraph, return control to the next instruction after the perform. So example is 100 perform 100 routine, perform 200 routine, perform 100 routine. So meaning just like calling a function name or a function to be performed from the main program. So perform 100 dash RTN with test after varying x from 1 by 1 until x2 is equals to 100. So from this example, it will loop from 1 to 100. After varying x from 1 by 1, it will increment 1 by 1. So from 1 will increment by 1, so 1, 2, 3 until 100. So the accept statement, uh, it is like the scanner of the program. So example, what is your name? Then accept the uh, the variable, or maybe then we display how old are you, then accept then age. So in order for us to accumulate this program, we also need to declare variables from the working storage section, which will be discussed later on. And then this is the output for the specific program. As you can see, we will also discuss how the variable affects with this kind of setups. So in these examples, we compared it to a Java program. So as you can see, the program ID is like a class, and the sample is the class name. The main is the main procedure actually. Then when we call the functions, this is like perform dash sub. Actually, it's a mistake on my part here, because this is the main procedure, and this like perform 200 sub can be compared to uh, void functions void functions, since Cobol program gets the data from the global setup. So basically, you can just call a specific function without sending any variable, because uh, you can just always call the global variable from it. So here we have perform 200 sub, which will be called, or maybe print 1, then we print it, then print world. So as you can see, if we compare it to Cobol program, this is the format of it. One So in main procedure, we display hello, and then we call perform 200 dash sub. So the output from Java is here, and the Cobol is here. So basically, so basically, so basically, this the Cobol program is somewhat the same with the other program or language, except the the format of the code will differ from the other, but the main idea is still the same. So in data division, just like here, we used to create a variables and constant fields. Only three data types: the numeric, the alphanumeric or text or string, the alphabetic. Uh, the level numbers indicate subordination of fields. Use levels 01 to 49. The alphabetic is seldom used. Actually, alphabetic is just like using alphanumeric. So I prefer using the alphanumeric. So in this example, we will discuss what is the pick or picture clause, and how we declare these variables. So we define data use in input-output operations. So example is file section, then FD customer file, 01 customer master, 05 cost num, pick 9 parenthesis 2, 05 cost F name, pick X cost parenthesis 20, then 05 cost L name, pick X parenthesis 20, then FD sales report is under 01 report area, pick X parenthesis 132. So the group item is a subdivided field. The elementary item is a non-subdivided item, a field. 01 is a group or independent item. You can also use 77. Higher numbers indicate subordinate fields. So yeah, as you can see in here in this example, the higher it goes, the the more it indicates the subordinate the being subordinate to the lower number. So we use 1 since it is a group. As you can see, customer table. We create a table of a customer which consists of customer record that occurs 100 times. So a table will have 100 customer name which consists of customer uh, last name and customer F name, and also we have the customer balance. Then we have the temp record and the I. So here the 66, 77, and 88 have special significance. 66 is used to rename, but it is no longer used. 77, an independent item. So as I've mentioned earlier, you can also choose 77, and 88 is the condition name. So here 01 triple X, 05 triple Y, 10 triple A pick X, 10 triple B pick X, then 5 triple Z pick X, parenthesis 20. As you can see, if you call the variable of triple X, the variable would return these values. If you call the variable triple Y, it would return these values. But if you call this variable, uh, it will just return its own values. So the picture clauses. So as we have seen the example earlier, picture clauses values usually use 9 x v s a. So why we use that? Or what are the meaning behind it? So 9 is use a decimal digit. So meaning it can be 0 to 9. X is any alphanumeric character. If you use X, it can be any character that is alphabet or numeric character. V is implied as a decimal point. So example, 9 V 9. So meaning my value would be example 0.0. S is a sign. So meaning if I put S ahead of 9, it would look like a positive 0.0. A is A to Z and a blank. So as you can see, As you can see in this example, the value here, this bracket, it signifies the number the x would return. So meaning x times 20. So since the value we have inputted is 4, 4, so minus 4, so 16 would become spaces before get arriving in this string. So for example, 9 parenthesis 6. So if we don't initialize it into values, we don't have any values for that specific variables. It will initialize to specific numbers like 0 for decimal, x for the x condition, the x. So here 9 parenthesis 6, it will generate 6 zeros. So if our like here, if our value is 4, the remaining would become like this: 2, 4, 5 zeros and 5. The reason why it is putted at the very last index is because it is it follows the rules of the placement, where if you have a tens values, so it should be putted in the tens values. Then next is 9 parenthesis 6 v99. So it means that we have 6 zeros followed by decimal and two digits of zeros. It can also be interpreted to this one. It may be it's if you compare these two examples, I would prefer this one since it is easier for my part to or maybe it is a shorter one. So next is the picture. You can also use picture or maybe pic. So x parenthesis 10, it will return 10 x's. So just like in pic, it was being written 10 times. So I would prefer to use this bracket to shorten the code. So in here, the other example is pic S9 parenthesis 4 V9 parenthesis 4. So meaning it has a positive sign, then plus 4 0 digits, then the decimal, and the 4 digit. Next one is S. So the next example is the same with this one, with the same output. The next is pic 9 parenthesis 18. It means that we have 18 zeros uh, declared in the variable. And lastly, pic x4 is the value of 4 ABC. So meaning we initialize the value of this one to 4 ABC. So another example here is triple x b double x b, then 4x. When I compile this, it just gave me a white space. I don't know why. Then next is uh, double nine, then dash. It is a date format. Then when I compile this one, it just gave 5 spaces. As you can see, alphanumeric the A that I mentioned, A, which is usually blank. So 5 spaces, it ignores the comma. Then or you can just use this one instead of V. Then 99, then the A sign, which will convert to uh, blank spaces. In here, it ignores the comma and combines the 6 asterisk, then dash, then digits. And next is it will just compile to 4 spaces and then dash decimal and then the 2 digits. As you can see here, it would just run or compile one sample of this, and the remaining would become the spaces. So as you can see, 2 spaces and then the symbol dollar, then digit, decimal, and 2 digits. And lastly, you can also write this one, a lot of nines dot 99. So if you want, if you're a type of programmer who doesn't want to write a long code, then use the parenthesis to shorten your code. So the usage clause, it specifies the format in which data is stored in memory. Normally, the phrase usage is omitted. So example of this, first name usage is displayed, pick x, parenthesis 20. So meaning it has an array of 20 20 size, can store 20 the size of 20 for the first name. And then so since it is omitted, we can just display first name pick x parenthesis 20. So the data division, it is defined and needed for internal processing in the working storage. So storage is statically allocated and keys for the life of the run unit. So our example, we have the total fields, which has customer total and the cost total, the date and time, which has the date, city, year, and the month. So as you can see, we have S9, which is positive, positive 7 digits, 7 digits, then decimal 2 digits, which has a value of 0. So meaning, the since it is being initialized to 0, uh, the 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 output of this would become like this. Same in this example. So if you recall, with other programming language, they use specific data types like uh, long, char, int, float. But in this example, we just have uh, maybe 4 or 5 data types to be declared. So this it is described data that exists in another program or storage you want to associate with a symbolic name in the linkage section. So the linkage section is under the part of the data division. So link data area, uh, which has a name and age. So meaning this in this section we're gonna getting data from another program, or maybe you're importing data from another program, just like the another programming language did. So the local storage is used to have storage allocated each time a program is entered and deallocated or returned from the program, used for compatibility with C or Java. So example is this one, local storage section. Then we have the customer number and the cost. So in working storage for programs is allocated at the start of the run unit. Any data items with value clauses are initialized to appropriate value at that time. So we have group and data items. As I've mentioned earlier, if the variable customer record is called, it would return this data, all data. So what really redefines means? So it is uh, to copy a variable value to another variable. So it means that when we copy the value of amount to amount x would have a value of ABC. So what happened to the left, to the right example? So basically, when you copy value from a variable, it would disregard some uh, some of it, like the symbol or the decimal. The only thing that it would copy is the alphanumeric or the digit only. That's why we have the the output of the first program, which is ABC. As you can see, when we redefine amount to amount x, the value of month amount, it only detects the amount but not amount x, because uh, the program doesn't gives values to the amount x, or in other words, that when we redefine amount to amount x, it it is executed, uh, or rather it is not it is not being saved to the month amount, but rather you can still access the value of amount x as the value of ABC. So at the right example, so just like our example from the left program, so when we redefine amount to amount x, so so our va- so our value of month amount would become the amount, not the amount x, since the value of amount x uh, would not be saved to month amount unless it was defined uh, or initialized just like the amount. So when we so our value for month amount would become uh, the three digits and the last two digits, which is, so 5 zeros, since we added the 3 and the 2 digits, plus since we initialize it to 99.99, so we'll just have to copy 9,999 in here. So our value for month amount would become 9,999. So here, so our amount would become a positive 99.99. So as you can see here, you're wondering uh, why we would have a value of 0.9999. So when we copy these digits, the values of amount, so we the the picture clause was being uh, the so we get our picture clause from here, from its subordinate. But if you don't have any subordinates, then you don't declare this one, then it would return an error, since it would needed the picture clause or its storage for the values of amount x. So as you can see, we have 9 parenthesis 5. So just like here, so our value of amount x would become 9,999. So as you can see here, we also redefined the x field. So why do we get x field with 9,999? So when we already have the value of this one, so it means we can give value to its subordinates. If we don't initialize the values for the x field, so when we redefines the x field to y field, as you can see, um, the value of peak x parenthesis 3 and peak x parenthesis 2, it would return x parenthesis 5, just like so this format is also the same here, but instead it is a digit only. So as you can see, when we redefine the y field, so we can still copy the whole x field to y field, but when we gave the value to each subordinates, you may notice that the value would become 0.99, since the value of since we have three working storage, we have three storage for the value of y field. So it's like trimming the value of y field. And then for the value of b, you may notice that I only have 99. So it means that the value 0.99 has been passed to A, and 99 is passed to B. So that's the meaning of redefines. So when we say literals, you may notice just like the example a while ago, if if the value is already defined, then you can display like this. So it prints the literals and literals. So S literals is the character literals, N is the number literals. So in order for us to have string literals, you need to use quotes. And for the n literals, we should just use we should not use the quotes. So constant is a data item that has only one value and it can never change. Unfortunately, COBOL does not define a construct specifically for constant. So moral of this, that all values are subject to change. So example, data division. So report header pick x parenthesis 50 value is equals to company report. So interest pick 9 decimal, then 9,999 value is 1.0265. So meaning this from these examples, you already define or initialize the values of each variables to it. So that is the constant. But you can still change it when you initialize it to the procedure division. So the figurative constant supplied by the language. So 0 is an appropriate form of 0. Space is the hexa of x40. The high values are binary ones. The low values binary zeros. The quote, single quote, null is binary zeros used for pointers. But this topic would is an advanced topic, so I won't deal with it first. So this is how you make tables in COBOL by doing having a keyword of occurs, like it would repeat this 2 times, and then for this one, since we're not going to use that for the activity, so I won't discuss it for now. But if you're curious about what is subscript, then you can chat it to the discussion board in GitHub. So the example of this, so when we go to this variable, so this variable should have not a peak because uh, it the new table would pick up the values from its subordinates. So meaning if you put a peak format or to new table, it would return an error. So as you can see, where we enter the subordinate of it, which is the 5 or the WSA, so it occurs 2 times. So meaning this this block would return 2 times. So meaning just like a double for loop, So when we loop this block, it would check here. So meaning it would save this value to WSB, and then it would check since it has an occurs 2 times. So when we loop this one, so uh, it loops 2 times. So meaning when we print this to our procedure division, it would look like sample. So it printed sample. Next, 2 times table. So that 2 times table. Then after looping this block, it would return to this block again to WSA. Then check the sample value would be saved to WSB. Then it would print sample. Then WSC occurs 2 times. Then print 2 times the table. So our example in here, so we define a number with a sign, 3 numbers, a decimal, and then 2 numbers after the decimal. By default, it should be filled with 0. So meaning the first var would return like this one, since the default value of 9 or the digit is 0. But if we put a value just like here in our second var, we can still possibly initialize it to negative 123.45. So we can also initialize an alphabet to the variable. So just like this one. So A, B, C, D, E, F is stored in A. In this one, we also store A121 to 4th var. But in this variable, a group variable, so when I will call the group var, it printed 337, la 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 la, la la la, and la la la. So as you can see here, this is the result of it. So when I will just call the specific of subvar 2, then it will just print la 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 la. So the move statement, it is used to copy data from one field to another. So example, move X field to Y field, Z field. So data is copied from sending field to receiving field. To move data from one field to another, the two fields should be compatible but don't have to be identically pictured. So alphanumeric, then our numeric. So the compatible moves would become alpha to alpha, alphanumeric to alphanumeric, numeric to numeric, and numeric edited. So if the receiving field is larger than the sending field, the receiving field is filled with zeros in a numeric move. So just like this, just like the earlier example, so if the value of it is larger than the sending field, so meaning our value, then so as you can see, our sending field is lesser than receiving field, meaning we will just put 0 to the left left value of the receiving field. So our example, value 123, so we will copy to S9 5. Actually, having value of 0, it is unnecessary to have that statement here, since when we initialize this one, it is already have the value of S9, the 5 zeros already. So this is known, this is not necessary anymore. So when we move x to y, so x to y, so it would become 1, 2, 3 plus the 0, the remaining zeros from S5, and the symbols, since it has a symbol in y. But if doesn't have a symbol, then the value that will be copied will be 0, 0, 1, 2, 3. So if receiving field is larger than the sending field, so it would filled with the trailing spaces in alphanumeric move. So as you can see, we have 3. This is our sending space, our sending field. Then our receiving field has 5. So meaning, when we print this one, we have remaining 2 spaces. We have to copy ABC, then copy to y value, and then remove the remaining letters to the y value, and filled it with the spaces. So that's why constant are not always constant, and that values are not always constant. So if the receiving field is smaller than the sending field, the data will be truncated on the left for numeric and the right for alphanumeric. Example for this is the sending has a 5, receiving has 3. So meaning the what does it mean? That data will be truncated on the left. So meaning the left value would be removed. So 1, 2 would be removed, since we have 3 for the y. So meaning positive 3, 4, 5 would be the value for y. So for the alphanumeric, it is on the right, meaning when we have when A has 5 and B has 3, we remove 2 to the last, and then copy to the B value. Actually, this one is not string literals, but it is a figurative constant. So meaning that spaces has a 1, it is stored 1. So meaning it has 1, then spaces, since our B size has 3.